My name's Todd Basher. Welcome to Zito. How do you like the new digs? Good? Yeah? Very nice. Okay, so in case you want to follow along at home, you can grab the Wi-Fi. And in case I move along, it's right up here, kind of hidden on this wall in invisible ink. So you can come over here and take a look at that. So, in case you had trouble parking, there are Zito spots in this lot right across the street and in the farther lot over there. Otherwise, drive around until someone leaves and then take their spot. Restrooms are through this door that looks like a fire exit, but they're back there somewhere, and that is a fire exit. There's one over there too. Hopefully we won't need it. So this is a professional event. We do have a code of conduct here at San Diego JS, and it boils down to be nice and be professional. If you want to read the whole thing, you can go to our website and check it out. We do have 3 organizers here tonight. Myself, Todd Basher. We have Stuart on the video recording, and we have Michael over there playing bartender right now. So come say hi when you get a chance. And we have a whole bunch of JavaScript related events going on this month. We have an Ember meetup on Wednesday. We have a couple of React meetups going on this month. We have our Bring Your Own Project night toward the 3rd week of the month, and then we have our Node Social Hour. So I encourage all of you to check out those events throughout the month. And as some of you may have read, Heather stepped down as an organizer, and we want to thank her for her tremendous contributions to the community over the years. So if you get a chance to see her, please thank her for everything she's done. And she mentioned in her email that we were kind of trying to take things in a new direction. And we don't really think it's a new direction. It's more of a recognition of where the community is going and where we would like to help it go. And this is kind of an evolution of what's going on. The meetup group has been around for a long time, and it's grown and grown. And throughout that time, we have seen members of the community who want to help each other and contribute. And so they step up, they become organizers, and it's become this great community of people that want to learn and help each other. And we want to continue that. And now we have like almost 2,700 people in our meetup group, and that's a lot of people. We have almost 100 people come to these every month. We have events. We have people coming up to us and saying, oh, I want to do an event, I want to help out. And so recognizing that, we as organizers want to formalize what we're doing, because we do have people contributing venues, we have people sponsoring our organization and giving us money to do these great events. So because we have these resources, we want to be able to coordinate with all of you to help you help each other. And that's really what our role is as an organizer, is to help you help each other. So over the next few months, we'll be working out how that goes. And in the meantime, we want to encourage you to hit us up with our Slack channel. So Slack is where you should go, communicate with each other, communicate with the organizers. It's sdjs.slack.com. And as part of an ongoing effort for the last few months, we've been working on a new website, and I'd like to show that to you for the first time. Just went up live today. So this is our new website. Nelson, who works at Webflow, generously donated his time and resources to get this designed for us and implemented. And so he's going to give a talk about that next month. But this is where you can go to get more information about the site. I also want to point out that if you do want to connect with us, this is where you can get a Slack, our Slack link. You can get our Twitter handle. You can go up here, get the video archive. So we have a YouTube channel. We try to record all the sessions here, so you can learn all that. And if you're interested in speaking, then please either hit us up in Slack or fill out this form and let us know that you're interested in speaking. We're always looking for speakers. This is you helping us help each other. So please check out the new site, give us feedback. If you want to start contributing, let us know through Slack. We're happy to have that. And another pitch, please go volunteer speak. We do have a number of lightning talks tonight, and this is our preferred format. There's basically, after 4 minutes, as a speaker, you'll get a warning. We do a little golf clap. Everyone follow along. Okay? And then at 5 minutes, we have a hard cutoff. Everyone starts clapping, and that's time for you to pack up and take some questions. If you are speaking, watch for your lineup. When your turn comes, before that speaker's done, come up here, get set up, and we'll get going. All right. Yes?
You completely blew the instructions.
Oh, sorry.
So I'm going to be the timer.
I'm a little rusty.
All right. I'll be the timer.
Yes.
And I will give hand gestures when we're at the 4-minute mark. And so the hand gesture for the 4-minute mark is I will raise one hand. At that point, you guys will do the... And then I will raise 2 hands, and that's when we do the... Ready, claps?
Like goal.
Unplug, and then while you're unplugging, the next person will come up and start setting up while you take questions. That way, as soon as the questions are done, the next person is ready to start presenting. So let's practice. Nice.
All right. Thanks for backing me up. All right. So Scott's going to go first, talking about componentry, and then we're going to have Corey coming up here talking about serverless websites. Trey's going to come up and talk about the fun and joys of learning to program. And Bill's going to come up and talk about web components. And then we're going to have a longer talk from Stuart. So we do accept longer talks. If you're interested in a longer talk, come talk to us. But Stuart's going to go 10-ish, 10, 15, however long he decides to go, apparently. All right. So that's it for the introductions. And like I said, this is just an evolution. We're looking forward to continuing to serve all of you, and I hope you enjoy the night. All right, so let's have Scott come up and go for it.
Okay. Okay, are we ready? Hi, my name is Scott Nakata. Tonight I'd like to talk about components in Angular 2, React, and Ember. There we go. So, what is a component? It's a type of data structure, or it's something that's now included in all 3 of the major JavaScript frameworks. It's like a custom HTML tag where you can define a view, or what the component should look like, and some JavaScript to control it. Examples of some components that I've created are in Angular 2, we just have the angle brackets, product list, some name, React product table, and Ember. Here we use the handlebars with the double curly brackets. In Angular 2, this is what a component definition looks like. You can see up here, I'm not sure if I have my mouse. There's a selector line which specifies the selector that you'll use as the HTML tag. You'll have a template where you specify the view, what it should look like when it's displayed. And then this class down here is where you can put your JavaScript statements to actually control the component. React has something very similar. Within the return brackets, you have your div, which is your HTML. You can specify some JavaScript statements to control the component there. And Ember has something similar. They split, or in my version of Ember, I split the control section into an appheader.js, and then I have a template components, appheader.hbs, which actually has the HTML or specifies the view. So, in doing this, I wanted to challenge myself, and I probably challenged myself too much, but there's a very nice article called Thinking in React, and it talks about how to use components within React. Well, I thought, we have components in Angular 2 and Ember now. What if I tried to apply those same principles to these other languages, and could I come up with something similar? So the problem in that article is your marketing person comes to you and says he wants a web page and he wants something that looks like this. A list of products separated by categories, products out of stock or in red. You have a search box to kind of sort the field and a checkbox to say whether you want to have the out of stock items displayed or not. Okay, let's do a quick demo. So I came up with a version of this written in React, and this one actually works because the article is based on this. But I can search for anything with the letter S in it. You'll notice that I still have one item in here that's in red because that's out of stock, and I can click this checkbox and have that disappear. I wrote something similar in Angular. Here you can type in the top box and select certain products, and again it's got a checkbox that takes away the out-of-stock items. And I started on an Ember version. I didn't quite finish it, but this is what it looks like so far. So, what are some of the important things that you need to do to be able to do that? In tackling a problem like that, the first thing you need to do is divide your project into multiple components. So in this particular case, we had one component in red for the product type, which has the product name and the price. We had in cyan, we have a component which is our product category row. And then in green, we have a product table. Dark blue, we've got the search box. And then in orange, we've got the overall structure for it. Once we've established a component hierarchy, we need to figure out which components will be inside of the other components. And this is what the hierarchy looks like in the three languages. After you've decided that, you want to figure out how is the data going to flow through the project. And that involves one-way data flow. All three languages support that. Angular passes it by just passing a parameter in the HTML tag. Same thing with React and Ember. Then you'll need to have state, which is usually a two-way data processing system, and all three languages support that as well. Okay. Any questions?
That is white. All right. So, hi, I'm Corey. I made this about 2 hours ago with low blood sugar, so we're both going to be seeing this for the first time. So let's see how it goes. It's about the kind of the future of development, what that looks like with static websites and serverless and all those other buzzwords that are going around these days. So first, some definitions. Serverless isn't quite accurate. There are servers. They're just servers you don't control, so who cares? You're not going to be getting the call on Christmas Eve about them. Microservices is what Unix is built on. Just small, little, single task, little programs that do one thing. Instead of a single app, instead of one big code base. And then service-oriented architecture is something that ties it all together. So it's kind of like this philosophy behind wrangling all these different little things talking to one another instead of one monolithic thing. Yeah, so developing features, not apps. Stop thinking about like the website as like the app. It's not your app. It's just a shell that delivers what your app is inside. It can be anything. It can be several different apps. It can be dozens of apps. There's no limit on how many things you can wedge into there. And this is not my dog. I just grabbed it off Google Images. But pretend this is Instagram 1.0. All it is just the photo and the user, and that's all it is. No likes, no comments, anything like that. So with a serverless website and developing microservices and building features like that, you can then add a like feature on top of that. So you don't have to touch your original database at all. You just build a new service that has its own database, and on the back end gets merged together, and then you have your like feature without having to touch the original code, really. At least the back end code. there's no reason to update your database. And then there's a microservice maybe on the back end that handles all the I/O, but you don't really need that. You can do it all from the front end with the cloud service providers these days. And then the great part of this kind of architecture is you can just throw it away and develop a new one, and it doesn't impact any other systems. So if we want to build a new service, we could just do it and launch it. And it's not efficient. You're going to be duplicating a lot of data, but who cares? It's, hard drives are cheap. So this is not new. Discuss. Everyone knows Discuss. Comments, Stripe, and PayPal. The buy button PayPal launched like 15 years ago. That is an embeddable app, basically. I saw a lot of components on there. That's basically a component, web component. All these things are same kind of thing, but you can take advantage of this system to build your next web app. So how do you kind of build in this new system? You don't need an FTP client anymore. So you just use modern CMS, Jekyll. Everybody familiar with Jekyll? GitHub's static site generator. But there's literally dozens and dozens of others now. And then you just use whatever content system you want, and then you deploy it to Netlify or any static web host you want. I prefer AWS though. And this is what mine looks like, my setup. Route 53 is just domains. Everyone's familiar with most of this stuff. Lambda is, you can basically shoehorn a single function into a scalable container that you don't have to worry about. You just throw it up there and it can scale from one instance to as many as you can throw it at. DynamoDB is the same thing. Is there NoSQL? Same kind of thing, scales. And then you just kind of throw some kind of authentication on the front end of it. Cognito, that's what I use. And then you can make calls right from the browser into your database, into Lambda, anything else, without having to go through a web server or anything like that. Then you put it all behind CloudFront, but that doesn't really matter. And then watch this repo, because there's nothing there right now. But I'm going to put up like a skeleton that has all that stuff I just talked about, and it'll be capable of basically letting you launch the next app that you want to launch and scale to whatever you want to scale to. And very simply. So.
Questions? Have you put this into effect yet and really discovered how hands-off it is? Or
Yes. Tens of websites are like that. So this will handle 99% of websites.
So the light video you described sounded like, and that's why you can push it off to separate server, and then would you say that microservices are better for what a microservice makes?
So S3 is eventually consistent, but DynamoDB is strongly consistent. Not across regions, but in the region it's strongly consistent. So you will have you'll have that if you want. It just depends. DynamoDB isn't going to cost you pennies; it's kind of more expensive. But if you need something like that, you can still get most websites for. Yeah. I use Cognito, and I noticed they recently expanded it with like an Auth0 competitor. I just haven't looked at it, but it looks like it'll eventually. Yeah.
Do you have any suggestions for?
Well, that's the great thing about it. You don't have to think about it. I look at code as disposable. So like if you design things this way, you can just throw it up, get it up there. If it doesn't work out, you can just tear it down and start over. And then since you're building on these services that are already established and well tested, then as long as you're making that the cornerstone of whatever your design is, it doesn't matter because it's. Yeah.
what are the pain points of developing?
So more junior developers can't think this way, and they definitely don't teach it in schools. So it's a different way of looking at things. It's kind of I kind of think about it like way back when you had a single threaded CPU, you didn't have to worry about multi-threads, but now you have to worry about scaling threads. Same kind of thing. You have to think differently.
I don't want to stop the audience from just peppering you with questions,
Yeah.
but we're going to have some time afterwards, so we're going to let the next speaker roll, and if you are willing to hang out after the presenters, people will continue to come.
So we are going to learn about learning. I figured there's too much computer science here, not enough cognitive science, and I don't know what I'm talking about when it comes to cognitive science, so you're going to have fun with this. So I don't have the skills that I do because I'm brilliant. I have the skills that I do because I acquired them over time through work, through play, and through a lot of help from other people. When you have a growth mindset, you know that you can learn the skills that you want to learn, but it will require work. You absolutely can do it though. Recognizing that struggling helps you learn is what actually makes struggling help you learn. So I'm going to say that again more clearly. Struggling helps you learn, but only if you recognize that struggling helps you learn. So the act of struggling is painful. That is what helps you learn though. So make sure that you are struggling and know that struggling will help you learn. This is struggling when you're actually learning something. If something seems easy, you're not learning. Have you ever heard people say practice makes perfect? Yeah, so there's a reason for that. Practice isn't about putting information in your brain. Practice is about retrieving information from your brain. Obtaining information is easy, retrieving information is the hard part. Testing yourself on what you've learned is often more important and more useful than rereading or rewatching something that you've already learned. So test yourself at the end of all the learning that you do, in between your learning. Test yourself early and often. If you consume information and you fail to test yourself afterwards, you will not learn. When you practice the same thing over and over, you'll feel smarter, but you are tricking yourself. It's more effective to mix up your learning. This is a little bit counterintuitive. So you should come up with different chunks of stuff that you'd like to learn, and instead of learning one, learning another, learning the third one, mix them all up. It feels confusing because you're learning multiple things at the same time, and you will feel like you're not learning as much. You'll feel like more of a hotshot if you practice each of these things at separate times, but you'll actually learn more if your brain is context switching between multiple things that you're learning that are related. If you're solving programming exercises, a good strategy is to randomize the exercises that you're solving that use different skills. Make sure that you're not solving the same, an exercise that uses the same skill back to back. Make sure it's related though. That's a big deal with this. So when I was in school, I crammed for a lot of tests. Cramming doesn't work. It allows you to remember something for a short period of time. You forget everything right afterwards though. Remember to interleave when you practice. You want to make sure that you're practicing multiple things at once, but you also want to make sure that you take breaks. Don't take breaks between topics. Take them at inconvenient times. Take them right in the middle of something. You want your brain to be working hard on something and then take a break, rip it away from it, let it background task a thing, and then move back to it later. Have you ever heard someone say that the best way to learn is to teach? Yeah, so when you explain a complex idea in your own words, you are elaborating. Explaining how things relate to each other is also elaboration. Whenever you reframe an idea or connect multiple ideas, you're strengthening your own learning. Analogies are one of my favorite ways to do this. If you can make an analogy between something and something else, some new thing you're learning and something you're already familiar with in your own life, you're learning right there. You're making a connection. Stop your brain from forgetting new things by actively retrieving things from your brain. As you quiz yourself, make sure that you're struggling and know that struggling helps learning. Don't participate in blocked practice. Interleave different skills when you practice. Take breaks often, but make sure that you're still interleaving. Practice elaboration. Explain an idea to a friend without using fancy software engineering terms. Make connections between different ideas. Make lots of analogies. Analogies are fun, they're silly, and they're productive. And most importantly, give a lightning talk at the next JavaScript meetup on something that you've learned, because elaboration is a good way to learn. So this is the book I got all this from. I was elaborating. Any questions? Reconcile the two. Both of them are mentioned in that book. And it was very difficult for me going through it to reconcile the different types of things that were talked about. But I would love to talk about that. Actually, we should just have a whole meetup on learning. Cool. Thank you.
Cool. So my name is Bill Heaton, and I've been a web developer for about 12 years. The last 4 have been focused on working with Ember. Prior to that, some Backbone and just general JavaScript frameworks that were kind of homebrew. But I've been really excited about web components. So 2 years ago, I don't know if you've experimented with them. Show of hands, web components v0 shipped to Chrome. We're like, yes, they're coming. 2 years later, v1 is shipped to Chrome. Yes, they're still coming, right? So this is definitely an experimental topic. It's not something you can implement tomorrow for profit. But like, where does it tie in, right? So earlier today, we talked about web components in Angular 2 and Ember and React. Almost each talk mentioned the word component. So the Extensible Web Manifesto has a lot of concepts on it. I don't know if anyone has visited that site. It's got a lot of great ideas, but it's about exposing low-level capabilities to explain features like HTML, CSS, JavaScript. Combine these together, boom, you have a web component. What's really nice about web components is if that was the standard, then you just build on top of standards. 10 years ago, we were fighting for web standards. Now we have evergreen browsers that are implementing these things. And one day there's version 1 web components. So that's pretty cool. So what are web components? How many people have maybe tried custom elements? A few? What about, has anyone used just like a template, like instead of a script tag to grab a piece of the DOM? I mean, that's shipped in all the browsers. It's been around for a long time. It's a nice way just to have a template. It's baked in. You don't need a framework for that. So web components are essentially 4 different technologies: custom elements, HTML imports, shadow DOM, templates. Shadow DOM solves like the encapsulation of your CSS. Like, so there's no bleed. That would be great, wouldn't it? Your Bootstrap doesn't bleed into your web components. You don't have to undefine things. So I'm really looking forward to that. Obviously, there's a great website about web components. You can kind of see where the polyfills are at. Right now, the polyfills for the version 1 spec are pretty busted up. So you have to kind of hunt around for those. There's a really great like custom elements IO. If you tag your package JSON with like web-components, hey, other people can discover what you're working on. You can discover what other people are working on. So this is a little project that I've been tinkering on and off for a couple years. Basically, they're alert boxes. You can kind of use these everywhere. Just imagine you have multiple systems that you have to support, but they all need to say, hey, your session's about to expire. Like, you should keep doing something, whether that's an Ember app, React app, or just a plain old EXT.js app somewhere, right? You could take advantage from these lower level components, which are just web components. So here's the shape of this web component. You have these slots for an icon, a slot for a message, a slot for a close action. That makes a lot of sense, right? And so then you have these little shadow roots, which are essentially almost like an iframe. Like, you just stick stuff in there and it lives just there. So there's encapsulation on the web. That's great. So what does it look like if your browser doesn't support web components? That one was Chrome. This one's everyone else. So it's not totally ready for prime time. And then you can see all the shadow roots are gone. Like, nothing's really that dynamic. So what does that look like? HTML imports are kind of the bane of like, oh, can I just import HTML into my site like I can CSS and JavaScript? No, there's still some security concerns around that. But generally, you would just wrap everything up in a file. So here I have a template. That's going to be the basis for my styles. The host is like, that's the parent of the shadow root, shadow DOM. So you'll have to read up on this stuff. It takes reading a few tutorials and trying it out a little bit, kind of like Trey talked about, learn something new. So I'm just going to kind of breeze through it. Anyways, there's a bunch of style. There's the shape of the HTML that you saw earlier. There's the slots. It looks just the same, in your editor. We're not using Babel or anything like this. These are just standards, right? And then JavaScript. What are the life cycles? Well, you get this disconnected callback and you get this connected callback. You'll see these types of interfaces in all the components and all the common frameworks right now, like did insert element or it's ready or something like that. But generally, all the frameworks are following this specification in some way and trying to test out the use cases, like what's working in real world apps. Eventually, this will land, and then there's going to be a lot more benefits. Oops. So, are they ready yet? Well, it's a working draft, right? Yeah. So, templates totally ready. HTML imports, you might want to use a build system to just concatenate your web components onto the end of your files. Now, why would you do that? I just want to show real quick, you can obviously look these things up on W3C, get more information. I think the good use cases right now are pattern libraries and interoperability. And there's great articles on this already. If you just search, can I use web components today? I'll post some links in our meeting later. But there's darn good use cases. So we're probably just about up. Any questions? Yeah.
I was going to ask you if you've looked at Polymer to fill some of these features like now.
I have not. Yeah, I've seen people that do, and it's great because it solves kind of like how do we take these ideas into today's browser. Things will kind of shape, right? You'll get all those in production, and then when the spec lands, you'll be like, oh, that's a different shape. So I can see why some people kind of pause, and I'm one of those persons kind of lean back on it, I'll experiment, but I'm really waiting for the spec.
Shadow DOM is in.
Yes, it is.
RE10.
Yeah.
It's in Firefox, so that part is actually Polymer.
Yeah.
Because they don't need what they were calling the shady DOM.
Yes.
With the fake Shadow DOM.
Yeah.
Anymore. And just to answer part of your question is Shadow DOM.
Oh, they do.
It's just DOM.
It's just us. So,
They
yeah,
just ignore that. They just ignore the shadow part.
that's what I was thinking.
It's just
yeah.
DOM.
It's just like a background image, right? Yeah.
Yeah, it's just like, it's not even that. It's like they can read the script tags inside of it. It's just more HTML.
Got it. All right. Well, thank you, everyone. Appreciate it.
All right, we'll see how well this works out. I'm going meta, presenting and recording at the same time. How's this volume? In the back, Ryan? You good? All right. Let's do this. So we're going to look at a lot of code right now. I hope you're ready. Basically, I work for a company in town called Zesty. We build a web content management system. And I had the pleasure of building a bunch of microservices around our media stuff. So we wrote a lot of it in Node, and we did a lot of kind of image manipulation. So I found it pretty cool. I enjoyed it, so I figured I'd kind of share some of that code and just give a general, like this is how you would upload a file from the browser, stream it to a Node service, maybe do some image manipulation, and then stream that to S3. So let's do this. I am going to have my Amazon console here. See if I can find this repo. So the official title of my talk is Stream a Little Stream with Me. I hope you can appreciate the reference. Maybe not. So basically, in order to get this going, what I have to have set up is I need an AWS account, which is a whole process. You got to put some credit card information in, actually be a real person. And then you need to have your permissions configured. So you have to either have a user who has permissions, S3 permissions, and heck, supposedly I got a lot of time, so why not just look at that? So as you will see inside of IAM, Maybe some of you are familiar with this, but this can be kind of complex sometimes when you first like dive into it, trying to figure it out. So what I did was I created a user, me. I clicked into that user. I set up some permissions. Here, how's that? Is that better? There we go. And then I attached a policy. So the Amazon S3 full access is what gives me read and write access via the AWS SDK. Maybe. Boom. Okay, so basically what I did is to kind of demo this is, how's this looking? Oh, is that weird? That's crazy. We got separate zoom levels for the console and the browser? News to me. So I got a little project going, and the way it's set up is basically I used Next.js, which is just a quick little like React thing, just let you whip up a quick page, just kind of set something up real quick. Supposedly you could take it and like build something with it. I don't know. So basically what I have here is I have my React component, right? So I'm rendering out some super simple HTML, okay? Right, I'm gonna have an on-submit handler. And if you notice here, my input is a file type with multiple. Multiple is what's going to allow me to be able to make command click selections to select a bunch of files. Then I have all this crazy stuff in here. So let's just go through this. Basically, you're going to have your event prevent default, and you need to stop the browser from doing what it wants to do when it gets a form submission. You need to say, hey, hold up, I'm going to handle this. I do a little selection to get my input. Then the input is going to have a files property. So I check the length to make sure I actually have some files to deal with. Otherwise, I just get out of here. And then I set up an XML HTTP request. Now you might be like, Stuart, why aren't you using the super cool new fetch API? And I'd be like, because it doesn't give you the progress event. Bummer. I know. I was just as bummed as you. Then I jump down here and I'm going to iterate over my files that I have. And then I'm going to append the file with the index attached to it, so it's a unique name, and then the file for that index onto my form. And as you can see, I'm using the form data. This is all like, form data is a pretty new API that's supposed to work in tandem with like fetch. Another thing that's kind of interesting to note here is this list of files is not an actual array structure, it's an array-like structure. So I can't do input.files.forEach. That method is not on there. So then we get into some of the more magical stuff where now I have this XHR object. I'm going to listen to the onReady state change. The XHR object goes through 4 state changes. The first is it starting, the fourth is it ending, and there's 2 and 3, don't ask me. So then once you get in there, I'm basically going to say, hey, so this is as, whenever that state changes, right, this callback is being triggered. So on each state change, I say, I can ask if it's been opened, right? This is the request opening up to the server, and I could do something there if I want to. What I'm going to pay attention to mostly is the request is done. When that's done, I'm going to check to see if it's a 200 or 201 coming off my XHR status. If it is, I'm going to see if it has some response text. I know this is JSON coming back from the server since I'm sending it back. Therefore, I'm just going to parse that, and boom, I got some JSON. Cool. Otherwise, if it's not one of these, it's a failure. It's not a HTTP status code I was expecting, so I'm going to do some sort of failure logic here. Upload event listener. So here's my progress. I'm going to log out my progress as we go along. I can listen to an abort. So if someone unloads the page, clicks away, maybe I give them a button to actually manually like, hey, like, you know what? I'm done. I don't want to upload this. Keep my cat photos. They can abort it. Errors. If an error happens, I can handle it here. I can then have the UI respond to that error. This is where I'm basically saying, hey, I have this XHR request. I'm going to open it up. So it's going to be a post to this URL. Okay? And then this is what actually kicks it all off, is sending this, and this is the data that I'm attaching to this post body. I have a little comment here about with credentials. So if you are building a production service, I'm going to assume you're probably dealing with authentication. If that's the case, you probably need to post your cookies to your authentication service. With credentials set to true is what does that. Now when the request goes off, the browser is going to know to grab all the cookies for that domain and then post them along. Cool. So now that we're set up, let's jump into some of this magic. So I have a server set up. I'm using an Express to run my server. Then Busboy is going to be my multi-part body parser. GM is graphics magic, so that's what I'm going to use for image manipulation. Pre-flight, so I have my own module here to handle pre-flight requests. We'll get into that. And then I have a module for uploading to S3, and then I actually generate my Express app. So I have this API app, and I'm going to set up a pre-flight middleware. So what I'm saying is, for all requests, since it's a wildcard, use this pre-flight middleware. So, has anyone dealt with pre-flighting before? Yeah? Yeah, it's a nightmare. I always forget about it, and then like I'm setting off these requests. I'm like, man, like what's going on with this? I'm getting all these like course denials, and I'm like, oh yeah, I'm not handling the pre-flight. So a pre-flight is what happens when you make a course request. The browser goes, hey, you asked me to post this data to the server. Well, let me ask that server if I'm allowed to do these different things. So it sends a bunch of headers, these access control headers, which basically specify, hey, I'm about to send you a request. These are the different details of the request. Can you handle this? And so your pre-flight needs to respond and say, hey, whenever I get this, these are the things I can handle. So what I'm saying here is access control allow origin. And this is when you do course requests, you'll see in your browser, it'll be like, oh, access control allow origin, not allowed from this domain. That's what this is talking about. So the origin is the domain that's making the request. So, this is where I get even confused. My domain is localhost 3000, port 3000, localhost. I'm making a request to localhost port 3001. So what I'm saying here is it's wildcarded. So I'm just saying, hey, any origin, any domain that makes a request to the server, I'm going to allow it. But if you're running like an authenticated request, or you know this is a request between your application and your service, you might say, hey, I only want to allow requests for my domain. And that way when someone is cracking open the console, looking at the request going to your service, to your application, and they're like, oh, hey, maybe I can sit here and just make requests against their service and abuse it, you can shut that down. So then you can specify the method you allow. So I'm saying you can post to me, you can do get requests, and you can do options requests. And then for the headers, I'm just going to send them back what they sent to me. So if they said, hey, these are the different types of headers I'm going to send to you, I'm just going, yep, whatever you want. And these could be custom headers. So maybe something you don't want to allow. So now that we've pre-flighted all our requests, the browser just asks, hey, can I do this? And we say, yep, you can totally do this. We're going to jump in and we're going to set up a route. So on posts, we're going to handle the upload route. Then we get into our busboy. So this is our multi-part body parser. So there are 3 different types of form posts. Yeah. There's the XML, XWW form encoding, whatever that one is. That's your standard old school form submission. That's what it's sent as. There is multi-party, and then someone help me out. Third one, maybe, I don't know. There's a third one in there. So there's multi-party. So multi-party is basically saying, multi-party is a module. A multi-part body is where you're going to have different types of data coming in, and you're going to have to handle that. So the busboy provides you a couple event listeners. You have an on file, so when it has a file event, and then you also have down here somewhere, maybe I deleted it. No, here it is. Field, and then you have finish, right? So pretty self-explanatory. File callback gets triggered whenever it says I have a file. Field callback gets triggered whenever it has a field. Finish callback is once the complete body of the form has been sent to the server. Okay, so field we're just going to ignore because I'm not sending any fields. But if you needed to deal with that, you could receive that data and attach that to your file or use it as metadata somehow. We actually do that at Zesty, but not what we're going to get in today. So, busboy, once you have a on-file callback, I get a couple of arguments here. I get my field name, I get my file name, encoding, and mem type. So, actually, let's do this. Comment that out for now. I'm cheating. I already set up a bucket. Typically, if you're building on actual service here, you're going to have to go and like either pull that from a data store, create it right then, whatever you're doing. There's an ACL. If you haven't heard of that, that's an access control list. This basically is specifying who gets access to this resource. I want this. I'm going to upload an image, and so I want it to be publicly readable, so I can demo it. So I'm going to say it's publicly readable. You can make that private. You can make it publicly writable. You can allow people just to straight write files to this if you wanted to. That's going to come down to your service. Here I have my upload my upload module that I've built, which is going to return me a promise. I'm going to push that promise onto an array of uploads. So now I have a list of uploads. The on data event, this is the stream part. So now that I have a stream, so file coming into me is a readable stream. Once I call the, oh boy, I messed that up. Once I call the on data event, that's what actually like kicks it into action. If you never call on data, it never reads from the stream. So I've had that before. I've sat there and been like, where's all my data? And then I never set up an on data. We're actually not, I'm doing this for just demo purposes. What's actually going to happen here is this file, which is a readable stream, is going to be passed into this upload. I'm sorry, I'm blowing this already. Changing code. So the file comes into readable stream. It goes into this upload module, which let's just jump into. And so it brings it in here as a stream. Then it gets into this S3 part. So first I create a connection to S3. I'm passing in my access key and my ID and my key. Then once I have that, I can call this upload method. And the upload method, so what actually happens with Amazon is they have, I'm not sure. They have an SDK which allows you to create a multi-part upload. But once you've done that, they start charging you. And you have to actually close it or abort it. I'm pretty sure what happens here with upload is it encapsulates all that for you. So it just opens that file handler up for you, starts streaming the data. Once it gets to the end, it closes that out for you, and that's the end of being charged for using their service. Otherwise, you could do that yourself. And that could actually be something you might want to do. Say you have like a large file, like say 1 gigabyte, and someone posts that to your server. Well, you might need to start sending that, open up that multi-part request. It returns to like a reference ID to that, and you just sit there, hold on to it, and you keep sending it, and say that request drops off, right? Or someone like aborts it, or someone like moves away from that view. You can then write that to a database, say, hey, this was the bytes they were at, this is the key, and now when they come back and they post that body to you, and you go, hey, that's the same one, I have a key for that, you can look it up. You can say, oh, well, this was the byte I was at. Let me just go jump straight to that and start re-uploading. And that's how you continue doing a large file upload. And then once it's done, you would have to manually close it out. So I use this upload method. I pass it some parameters to say, hey, this is the bucket I want it to go to. The key is the file name. That's what's going to be the reference to this file object. The ACL that I set up before I pass in. The stream is the readable file stream I'm piping in here, or not piping in, but passing in. And then I have my callback for when it's done. I also set a mem type. The mem type is super important. The mem type, the provider is going to write to that file, and when it receives a request to get that file back out, like say from the browser, it's going to return that mem type as the content type, and that's what's going to inform that client on what this is and how to deal with it. So if you don't set this or do not set it properly, a lot of times what happens is it defaults to like an octet stream, which is basically just a binary stream. The browser goes, hey, I don't know what this is. It's a binary stream. Just download it. And that's why you can get to a situation where when you upload, you don't set your content type properly. You go to click that link and it just starts downloading a file. You're like, whoa, how come it's not displaying this image? So for like an image, it would be like an image / like JPEG or image / PNG. That's the instruction to the browser that says, hey, don't download this file, display it to the user. So super important. and can kind of get you if you're not paying attention. Yeah, so that's like the code that actually submits this to S3. So we'll keep going down here. So now that and as you can see here, I've wrapped it in a promise. So it just returns this promise. Once it's done, it either rejects it if there's an error or resolves it. I return that promise. I take that promise here. I push it into this array of uploads. Now I have a list of promises. So now, once I'm down here on my form finish, so what I say is, once the data from my client has finished submitting to my service, I'm going to do a promise all. So promise all takes an array of promises, and then once they've all completed, returns them as an array of results. Okay? Super important thing to note here, this fails fast. So what that means is, if there's a single failure along one of these promises, it just fails the whole thing. The rest of the promises do not complete, the whole process fails, and you get an error, which I'm catching here. Maybe that's what you want, maybe that's not what you want. Like maybe you're gonna do like a multi-file upload, and if one fails, you're like, I want the other two to complete, and then just fail that one and send back that response. In that case, you'd wanna do something a little differently. For our purposes, we're just gonna let it fail. And then here, so this is the magic that kind of kicks it all off. So we have our request object, which is an instance of a stream because it has a pipe method. I'm gonna go with yes. It has a pipe method, so I'm gonna say it's an instance of a stream. And what we're saying is we're piping this readable stream. I'm sorry, we're piping this, wait, what are we doing here? Yeah, we're piping the request, which is a readable stream and is gonna have all the request information on that. We're piping that into this other stream, which I believe is a writable stream. And this is the busboy instance. So this is how it's all gonna break down. That request comes in on the request object. That pipes to the busboy instance, which then reads the data off of that request object. It then, as it gets a file, right, it says, hey, this is like a file. I need to trigger the file handler. It reads, it has an onData event on that file. When it gets that data, it takes that data chunk and then passes it to my handler, okay? And that would be this portion right here. I'm sorry, no. This portion right here. So this would be the chunk it's reading off. Instead, what we're gonna do is, when it gives us that readable stream of the file, we're just gonna pass it straight through to this function, which then takes this stream, which is now that readable file stream. We attach it as the body of this parameter. Now when S3 sets up its file object handler, it now has a reference to this readable stream. It creates a writable stream and handles setting up the onData method, pulls off the chunks of data as they come through, and then sends them to that writable stream, which is actually what writes it to S3. Yeah, so let's just do it. Why not? So I guess the first thing we should do here is restart this, since I made some code changes. We're gonna choose, maybe. All right. We're gonna choose a file. Let's see. Let's go with BMO. So now you can see we have, this is a file reference on that input parameter. We have our log here, so we're gonna send that. Boom, progress 100. Basically instant because there's nothing in the way. If you're doing like a real network request, you would see some loading progress on that. We can see I got a success object back. This is just the object that's being returned from S3. I just sent straight back to myself. So here, boom, I have all this information about this request. I have a link to the resource it just created. So let's see. Oh no! Live coding demo fail. Maybe. 403 forbidden. Something sounds like my ACL is incorrect. So we're gonna just quickly hop into S3. Let's take a look at this and see. So here's my bucket. File got there. 0 bytes. That's gonna be a problem. So it's the classic changing code mid-talk.
You comment that stuff.
Yeah, so I wanted to first show uploading before show file manipulation, but maybe not. Oh, wait, no, that's coming in, right? All right. Well, let's give it one more go with the code the way it was. Oh, and as you can see here, so this is the buffer of that as it came through. So that's me just logging that data. Let's try this one more time. So I still have my file here. I should just be able to send it again since it's still in memory. Progress goes up. Well, there it is with the image manipulation. So, see how much? Oh, we can close on time. Okay, so real quick, why streaming? Like, why even go through all this effort? So the traditional way, if you've done this in the past, is you get that file. You write it to your disk, you temporarily hold it there. Once you've got it's all come up, it's all been written to the file, you're like, cool, I got the file. I'm gonna reread that file, then I'm gonna post it somewhere else, right? So we're using disk consumption there. So we have to have disk space available. So if we're building a production service and just megabytes coming at us, we have to have space available for that. So that's a scale issue. We have memory consumption. So now it has to upload the whole file. So say you have a 200 megabyte file, all that is consumed memory. Before once it has it all, it can write it to that file, to disk. So we avoid that. We avoid, oh no, this is getting real bad, low battery. We avoid disk I/O. We reduce our memory consumption. So we're running cheaper servers and we're running faster servers. Pre-flight types of streams. So we have 4 types of streams. We have readable, writable, duplex, and transform. Readable, writable are pretty self-explanatory. Duplex is just both. It's a readable and writable stream. A transform stream is where it's changing that, it's mutating that data as it's coming through the stream, which I would assume is what the graphics magic stream is, since we're altering that data. Oh yeah, magic numbers. So the mem type is information you can actually retrieve from any file. So every file has a couple of characters at the very front of it that tell you what that file type is. So you can actually, if you wanted to, write your own mem type sniffer, where you could put in front of, in between, whatever stream you have here and the stream coming in, you could put this module which has the stream come through it, reads out the first, 16 kilobytes, looks at those first couple characters, does a lookup against, some sort of record that you have on hand, and says, hey, these characters match this file type. This is the mem type of the file. And so that could actually be very important, because I could have a JPEG and I could just change the file extension, right? And I can just post that. Or I could have, let's say, an executable and change the file extension and post that to your service. Well, if you're just looking at the file extension and you write that as like the mem type, that might not necessarily be what it is. So it can be an important thing to kind of consider. When working with Node.js streams, it's important to note that there's been like a couple iterations, primarily 2 versus 3. Most modules are streams 3 now, but if you are using, if you're just going out grabbing some random package and using it, and all of a sudden like things don't line up, you're not getting the response you're expecting, you might want to double check and just make sure it's not a streams 2 implementation. As a consumer, it's really something you shouldn't have to worry about. There's ways to get around it for authors. If you're an author, you should be very concerned about the different versions you have and what you're supporting and how your consumers use that. So if you're an author, please be kind to us. The way a stream works is the data comes in. It has an internal buffer. This is the beauty of the stream, is with the internal buffer, it's going to handle what's called back pressure, right? So it only has so much space inside this stream. And so it requests the data. It says, hey, I've processed this chunk, give me this next chunk. And then it handles that, and then the next chunk. So you don't have to worry about flooding the stream. You don't have to worry about getting that next piece of data into the stream. These are the mechanics that it handles for you, and this is what really makes it beautiful. especially for an author, like as an author, the interface around that is just super, super easy. As a consumer, it's almost like a no-brainer. I say that with crossed fingers as I struggled through implementing streams, but once you kind of get it, it makes sense. And once you figure out like what works and like what you're looking for and how to make those pieces connect, you kind of have a frame of reference to go back to. You can control that buffer on a stream. So streams have what's called a high watermark, and that's the size of the buffer. So you can say I want 16 kilobytes, I want 24 kilobytes. You can control that. So for some reason, that's a requirement. That's available to you. That's it. Questions? Bill.
Quick question. So one thing that's interesting to me about streams is you're reading part of the file first, right? Have you handled a use case where you want to identify that file as something that's already been uploaded? And if so,
yeah. So what we did at Zesty was we actually have a mechanism that guards against that, where the file comes in. When we first get that file, we actually, because you see the file name,
yes.
And typically with providers, those file names are like the unique keys. Like you can only have one file of that name within that bucket or that container. We make a request. We say, hey, do you have this file name? If it does, we actually generate a short ID and append it to that to create a unique file name before we upload it. So yeah, you would have to reach out to wherever your persistent storage is to ask that question. So you're going to have some sort of network request, but definitely possible.
Yeah, I was thinking about those buffers, right? You get a few buffers in, you have a certain amount of bytes, you can do a hash off those bytes and say, here's what I think the signal, regardless of the file name.
Yeah, I guess you could. Yeah, I mean, I guess it would depend upon whether or not the buffer strings are unique enough, like when that hash or how you're hashing it, to determine the uniqueness of that. But yeah, I don't see why you couldn't do that.
Well, the client might
Yeah.
not know. They're like, I got this 2 gigabyte video I want to upload. Here it is.
Right, but you can grab the unique file and send that signature.
I probably wouldn't hash. I'd probably use the file name as unique identifier, but I'd probably keep like it in memory or maybe like a Redis cache, something like that's like super fast.
Yeah.
But yeah, it's definitely doable. Any other questions? All right, cool. Thank you.